Pseudo calculus problems. We have started a discussion in pseudo calculus problems. And in pseudo calculus problems, we are calculating surface area of a circle. Okay, people would laugh that what is there in area of the circle. Area of a circle is pi r square. Everyone knows it. Pi r square. Just do pi r square and it would give the area of a circle. But how pi r square is derived, that people they do not understand. If someone is given a task of calculating the area of a circle, then certainly he would not be able to do at all. That is guaranteed. What is the area? What is the area of a circle? Okay, this is a probably this is a very simple question. What is the area of a circle? Okay, if I am trying to find area of a circle, there are many ways finding to. I believe three ways we have already seen. Finding the area of a circle. Finding the area of a circle. And in all of the way, I mean, first way was simple, that is height into width. Height into width is area of any two dimension. Height into width is area of any dimension. If I take, we're talking about pseudo. If I take a simplest case, then this is height and this is width is the area of a circle. Height into width is area of a circle. Makes sense? Okay. Now, in that way, if I am trying to calculate area of a circle, then I'll take a simple case, that is a rectangle, and calculating the area of this rectangle should, we will proceed from there and we will tackle the area of a circle. What is this area of a rectangle? Area of a rectangle is height into width. Okay, from there, height is y and width is x. Y into x is the area of a rectangle. Y into x is the area of a rectangle. Okay, if y, that is the height, is dependent upon x, then y can be written as fx, function over x. Fx into x is the area of a rectangle. Fx into x. Now it can be generalized that fx into x is area of any shape. Now we came to a level where function over x, that is the y, is changeable when x is changing. If it is a rectangle, then function over x is constant. I'll rephrase it. I'm trying to calculate area of a rectangle, and this height I call it y and width I call it x. This is y-x plane. Area of rectangle is y into x. Y into x. Y is constant everywhere. If I see, y is constant everywhere. All along the x, if I take height, it is constant. But we will proceed because we started with the simplest case, y into x, but no guarantee that y will be constant. Y may vary. Okay, if I take x axis and y is the height, y may vary. If y is varying, then y will become dependent upon x. At different x, y is different. In that sense, y will become function over x. And if it becomes function over x, then fx into x is the area. If it is fx into x, it is a fit case to convert this multiplication into integral calculus, and that is fx dx. Function over x. Y is the square root of a square minus x square for the circle. Now area becomes square root of a square minus x square dx. X is from minus a to a. This is how we pseudo calculus problems we started. Then we found no. To find the area of something, we can have this vector and this vector. Do cross product of these two vectors, you will get the surface area here. This vector and this vector. Cross product of A vector and cross product of B vector. A cross B will give the surface area vector. Magnitude of A cross B would give the actual area. Okay, in that sense, A is a straight line vector, B is a straight line vector. Means B is a vector that represents a straight line. A is a vector that represents a straight line. If that is the case, then A cross B is the area vector. But here there is no straight line. Okay, x-axis can be consider this as x-axis. Consider this is x-axis. This is a straight line. This is y-axis, and y-axis line is not a straight line. X-axis line is a straight line. Y-axis line is not a straight line. If I do cross product of x-axis and y-axis, I need to represent not a straight line into a vector form. So A means along x-axis and along y-axis. A cross B, or A is this and B is this. A cross B is the area vector. If A is the curved line, then what is the vector representation of a curved line? Okay, anyway. Now, if we talk about the, means we're trying to calculate area through cross product of two vectors. Okay, now if I represent A as xi plus yj and B as xi plus yj, if this is a rectangle and this is origin, if I move along this is B vector. This point is x2, y2 and this is x1, y1. In that sense, A vector is x1i plus y1j. B vector is x2i plus y2j. A vector, B vector. A vector cross B vector is a surface area vector. If I remove x1 and x2, then it is x1 xi plus yj cross product with xi plus yj. One is along x-axis and one is along y-axis. If I take a straight line, then x-axis means I can take out x from one side and y from one side. Because if I represent a vector in y by x or x by y, then actually it gives the relationship between y and x, that how y is changing when x is changing. Or if I represent in x y y, then how x is changing when y is changing. Okay, in that sense, first vector, now we have vector area vector in xi plus yj, xi plus yj. First I take out x and another I take out y. It becomes I plus y by xj. I'm sorry, yeah, I plus y by xj bracket close into y. Cross product with xy y I plus j bracket close into y. If I modify, if I take division as differentiation and multiplication as integration, it becomes I plus dy by dxj bracket close into dx cross product dx by dy I plus j bracket close into dy. More or less it will become I plus dy by dxj bracket close cross product with dx by dy I plus j bracket code dx dy. Now here two independent variable came, dx dy or dxy plane, means x and y are independent to each other. Then only we can proceed in this fashion. But x and y are not independent to each other. Y is dependent upon x. We cannot proceed in calculating the surface area by cross product of two vectors, because if I proceed with a cross product of two vectors, it ends up in dx dy. So if I want dx and dy, then I have to go with the three dimension. And in three dimension, we try to calculate the surface area when we have a height also. That sense, circle becomes a cylinder and rectangles become a cuboid which has a height. We took height as 1 and then we proceeded and we calculated the surface area of a circle. Or we took height as a 1 and top surface area we calculated, considering it will be same as the bottom surface area. If I take it as cylinder and top surface area, if we calculate, it will be same as the bottom surface area. Then again we calculated the surface. What can be fourth way calculating the surface area of a circle? Circle is best represented as a polar coordinate system where there is a radius there is a radius, and radius, this circle is centered at the origin. This is radius, and radius is moving like this in 360 degree. Means there are two components, they are variable here. Radius is variable, but right now if I take a fixed circumference, then radius is constant, but still radius comes in a variable here, and theta is varying. Okay, then it makes the, I'm sorry, radius is variable. Radius is not the parameter. If I'm talking about the surface area of a circle, not perimeter of a circle, surface area of a circle, then this radius grow from here, origin where radius is 0 to radius A. An angle grows from 0 degree to 360 degree. Now, this makes a circle. Okay, how we calculate the area of a circle? Through polar coordinate system. Try any coordinate system. I want the surface area of a circle. Thank you very much. Okay, what is the circle? Consider this is Cartesian coordinate system. This is xy plane. This is xy plane. This is x-axis and this is y-axis. This is xy plane. Consider there is a theta r plane. There are two planes now. Theta r plane and xy plane. Two planes. In theta r plane, I have a rectangle. Makes sense? And in xy plane, I have a circle. In theta r plane, this axis is theta and this axis is r. Okay, in theta r plane, this axis is theta and this axis is r. I believe it is alright. Now, consider that there is a point here called r comma theta. There is a point here called r comma theta. R comma theta. Accordingly, there will be a point here on circle somewhere. It is x comma y. Okay, what is r theta and what is x comma y? Consider that in xy plane there is a circle and theta r plane there is a rectangle. Understandable? Now x is related to theta and r with some function, and y is related to theta r with some function. What is that function? X equal to g theta comma r. G is a name of function, small g, bracket theta comma r bracket close. Y is h theta comma r. X is function over theta comma r, g function, and y is function over theta comma r, h function. What is x? X equal to r cos theta. Make sense? Y equal to r sin theta. They are interrelated to each other. If that is the case, then if I have a rectangle in r theta plane, it will exactly map into a circle. Someone can try. Now, if I take any point here as r comma theta, accordingly it will map to some point here, that is g theta comma r comma s theta comma r, because that is x and y. X equal to g function over theta comma r and y is g function h function over theta comma r. Now, at any point theta comma r, in theta direction I move delta theta. In theta direction I move delta theta, and in r direction I move delta r. How much I need to move here? Consider this point here, that is x comma y. His point is, I believe, is, I'm sorry, I will rephrase this. This is center of the circle in xy plane. This is a point called P. P point is x comma y. This point is exactly mapped to another point in theta r plane called theta comma r. This point is x comma y P, where x comma y is nothing but g theta comma r comma h theta comma r. G theta comma r is x and h theta comma r is y. Now position vector of P is xi plus yj. I believe it is alright. Now in theta comma r is a point somewhere on this. This is theta axis and this is r axis. Now in theta comma r is a point somewhere here. I move delta theta, then new point come as theta plus delta theta comma r. I move delta r from theta comma r point. Theta comma r point, corresponding point here is x comma y. Now I move in vertical direction and new point is theta comma r plus delta r. Now what are the 3 points here? One point is x comma y, that is g theta comma r, h theta comma r. Another point here is p1, p, p1, p, p2. Here we have theta comma r, that is representation of p point. Then another point is theta plus delta theta comma r, and another point here is theta comma r plus delta r. Similarly, we have point here. One is g theta comma r comma s theta comma r, and one is g theta plus delta theta comma r comma h theta plus delta theta comma r. This is p1. This is p g theta comma r h theta comma r. If we move up, then this is p2, that is g theta comma r plus delta r comma h theta comma r plus delta r. What is the area that is formed because of p, p1 and p, p2? Here area that is formed because of three different points is delta theta comma delta r. Makes sense? If there is a point called theta comma r, and from this point if I move delta theta and delta r, the new area that is formed is delta theta delta r. Delta theta delta r. Here, here in on the circle we have earlier point was p, then one point came as p1 and one point came as p2. P1, what is the area in between? Area in between is P1 P vector cross P2 P vector. If I have two lines, if I make cross product, it will give the area in between. Here it is straightforward. Delta R, delta theta, delta R. But here it will be P2 P1 P vector cross product with P2 P. What is P1 P1 P? P1 is g theta plus delta theta comma r h theta plus delta theta comma r. If I talk about P1 P vector, then it is g theta plus delta theta comma r comma h theta plus delta theta comma r minus g theta comma r comma s theta comma r. This is P1 P vector. Cross product with P2 P vector, that is g theta plus g theta comma r plus delta r comma h theta comma r plus delta r minus g theta comma r h comma s theta comma r. This is the area that I see in xy plane. If I make one small area in theta r plane, delta r correspondingly, I am getting another area here in xy plane as P1P cross product with P2P. Okay, what is the change in the what is the area? What is the area of the circle? What is the area of the circle? Area of the circle is P1 cross P2. Hop, 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 hop. Okay, what is area of the circle? What is area of the circle? Area of the circle is P1P cross P2P. This is abstract mathematics we are talking about. This is the area of the circle. Here, where circle is represented in x and y represent a circle, and it is controlled by theta and r in another plane. If theta and r moves from here to here, theta and r from here to here, if they move like this, then x and y move like this, because that is the relationship. X equal to r cos theta, y equal to r sin theta. What is the area of this? Area of this is delta theta, delta theta into delta r expanded for this full region. Similarly, what is area of this? P1P cross product with P2P expanded for the full region. Because if I make delta theta and change it over full width, and delta r change it for full width, then multiplication of theta and r will give this area. I believe it is all right. Means area in xy plane, area in, if I say that area in xy plane and area in theta r plane, what is area in xy plane? Consider, I know what is area in xy plane, that is A. What is area in xy plane is A. Then A equal to A by theta r into theta r. What is area in xy plane? Area in xy plane is A. Then A is same as A by theta A A by theta r into theta r. I believe it is alright. A by theta r into theta r. If I say A by theta r means in theta r per unit change in area brings how many unit change in area in xy plane. If I say y by x means along x axis, if I make 1 unit change, then how much I see change in y axis, that is y by x. If I say area in xy plane is A, then A by theta r into theta r, same thing. Then how much area change I see in A when I have a 1 unit area change in theta r. Okay, that is same as that if I take a delta r area change in theta r plane makes how many area change in xy plane. If I divide it, I'll get exactly because full full this is if I take this as full theta and full r, then it corresponds to this circle. This is the relationship x equal to r cos theta and y equal to r sin theta. If I take this as a circle and this I consider as a radius, then and this is the angle. Radius cos theta is x axis, radius sin theta is y axis. Okay, in that sense, the relationship is that if I multiply r and theta in r theta plane, then it will give the area in xy plane. Okay, in that sense, what is change in the area in xy plane if I make the 1 unit area change in theta r plane, dA in xy plane by d theta r into d theta r. I can write like this. I will rephrase this. Okay, probably I'll take one more session on this. If I know the area in xy plane is A, then A equal to A by theta r into theta r. This is theta r, theta into r. This is theta r plane into theta r. If that is the case, what is A by theta r? If I change in what is if I say y by x, 1 unit, per unit change in x brings how many unit change in y? That is y by x. If I say 10 by 2, that is 5, means 10 by 2 means per unit change in denominator brings 5 unit change in numerator, that is 10 by 2. If I have A and I say A equal to A by theta r into theta r, then per unit change in theta r brings how many unit change in A? Where A and theta are related to each other. A means circle area in xy plane and theta r is the area in theta r plane. In theta r plane it is theta into r. If I take any point here theta comma r, then if I make delta theta and delta r change, then the area I see change here is P1 cross P2. So if I divide P1 cross P2 divided by delta theta delta r, okay, then numerator I have said theta into r, that will also become delta theta delta r. This is the exact expression of area in the xy plane. The area in the xy plane is P1 cross P2 divided by delta theta delta r into delta theta delta r. Means how much area change I see in xy plane when there is delta theta delta r unit of change I see in theta r plane into theta r plane. This will, if someone talks about the actual mathematics, then numerator and denominator they will cut down and we will see only area in xy plane. This is what we are looking. If I say area in xy plane, then it is area in xy plane. This is abstract term. I'm saying A is area in xy plane. That is abstract term. I don't know what is area in xy plane. Then I say area in xy plane is same as area in xy plane by area in theta or plane. If this is area in xy plane and I have a relationship between this is x axis, this is y axis. If I have a relationship between x and y, theta and r, this area will correspond to an area in xy plane. I'm sorry, in theta r plane. If x is going from minus a to a, then r will go from one location to another location. If y is going from minus square root of a square minus x square to square root of a square minus x square, then theta will go one location to another location. It will form typically a rectangle and this will form a circle. Now, if I know that circle area is A, that is abstract, that actually I don't know, I just write A, then A equal to A by theta r into theta r, which per unit change in the area in theta r plane brings how many unit of area change in A. Actually, it was A earlier, that was the area. If I say I have amount called 10, thank you, 10. 10 equal to 10 by 2 into 2. What is this? As per mathematics, 10 equal to 10 by 2 into 2. What is 10 by 2? Per unit change in the denominator brings how many change in numerator? All of a sudden it started happening. I have a quantity called y. Then y equal to y by x into x. What is y by x? Per unit change in x brings how many units of change in y into x? Somehow, from somewhere, like if I have area of in xy plane as a, then a equal to a by area in theta r plane into area in theta r plane, same thing. But if I have a by area in theta r plane, it is as good as if I make 1 unit of area change in theta r plane, how many unit of area I change in xy plane. Makes sense? Now it is very much all right. If I have area of this is a, then a equal to a by area of theta r plane into area of theta r plane, as per simple mathematics. Now what is a by area in theta r plane? That is 1 unit of area change in theta r plane brings how many unit of change in area in this, that is dA, and it will become a differentiation because both are related to each other. The numerator is in x and y because this is in x and y, and denominator is r and theta. R and theta are independent components, and x and y are function over r and theta because we talked about that. Means this division will become differentiation. Earlier it was a by theta into r, or area in theta into r, will convert it into dA by d theta r. Okay, as per the calculus, division will become differentiation if numerator is dependent upon denominator. Per unit area change in theta r plane brings how many unit of area change in numerator. Now, if we make delta theta delta r unit of area change at any point theta comma r, it brings P1 P cross P2 P area change in numerator. Makes sense? Now, in denominator, we have delta theta delta r, and numerator, we have P1 P cross P2 P. Okay, P1 P is H, I'm sorry, G theta plus delta theta comma R, H theta plus delta theta comma R, minus G theta comma R, S theta comma R. Cross product with G theta comma R plus delta R, H theta comma R plus delta R, minus G theta comma R, S theta comma R, by delta theta delta R into, we have theta r already in numerator, that is kept like that. Okay, theta I'll keep this side, P1P, and delta r I will keep that side in the cross product. Now we have P1P by delta theta cross product with P2P delta r by delta r. It becomes G theta plus delta theta comma r comma H theta plus delta theta comma r minus G theta comma r S theta comma r by delta theta. This is exactly same as differentiation of, means d of G theta comma r S theta comma r by delta by d theta. If I ask someone what is d differentiation, d of theta comma r comma, I'm sorry, d of g theta comma r comma h theta comma r by d theta. He will say g theta plus delta theta comma r h theta plus delta theta comma r minus d theta comma r comma s theta comma r by delta theta. Same thing is there. Now it becomes d theta comma r s theta comma r by d theta cross product. Similarly, that side will become d differentiation of g theta comma r h theta comma r by dr. Okay, now g theta comma r s theta comma r is x comma y. It becomes dx comma y by d. I'm sorry, dx comma y. Okay, I would rephrase this. I believe we misled somewhere. Anyway, what is P1 P vector? We know that now at the end we came to a position where the D area by D theta R becomes P1 P vector P1 P by delta theta cross product P2 P by delta R. P1 P is G theta comma, I'm sorry, G theta plus delta theta comma R comma H theta plus delta theta comma R. Okay, so if I talk in kind of in a vector form, because this is a vector, P1 P is a vector which is I and J, then it becomes in vector form. If I talk in vector form, then it becomes G theta plus delta theta comma R minus G theta comma R I vector. I believe it is all right. Plus H theta plus delta theta comma R minus H theta comma R J vector by delta theta. Or if someone talks in points only rather than vector, then it becomes G theta plus delta theta comma R minus G theta comma R. I'm sorry, G theta plus delta theta comma R comma H theta plus delta theta comma R minus G theta comma R comma S theta comma R, 2 points. But if I talk in vector, it becomes G theta plus delta theta comma R minus G theta comma R I vector plus H theta comma R theta plus delta theta comma R minus H theta comma R J vector by delta theta. It becomes dg by d theta I vector plus dh by d theta j vector. Okay, or dgh by d theta, whatever form for anyone want. If I see in vector form, then dg by d theta, g is x, dx by d theta I plus dy by d theta j, or d of xi plus yj by d theta cross product. Similarly, that side will become d of xi plus yj by dr. If I say x comma y is a position vector p, then it is dp by d theta, dp by d theta cross dp by dr. Makes sense? See, from where we started and we came to a position where we have now the area as dp by d theta cross dp by dr. P is a position vector of a point x comma y. That point x comma y is a mapping from theta r plane point called theta comma r. Here it became now dp by d theta cross dp by dr into theta into r. Since we had taken here delta theta delta r is denominator, numerator will also become delta theta delta r d theta dr. So area vector becomes dp by d theta cross dp by dr into d theta dr or d theta r. We started that area is A. In xy plane area is A. Then A equal to A by theta r into theta r, where theta r is the area in xy, area of the in theta r plane, that is a rectangle. How it is a rectangle? Someone can try drawing x equal to r cos theta, y equal to r sin theta. If x is a circle, then r theta plane it will be a rectangle. Someone can. This is the association we have made. In that fashion, if A is the area in xy plane, then A equal to A by theta r into theta r, where theta r is the theta into r is the area, or area in theta r plane into area in theta r plane. Area in xy plane by area in theta r plane means y. Division means one unit area change in xy plane brings how, in theta r planes brings how many area change in xy plane. If I say z by x, means along x axis, if I make one unit change, then along z axis, how many unit change is happening? That is z by x. If I say area in xy plane by area in theta r plane, means one unit of area change in theta r plane brings how many unit of area change in xy plane. But xy plane and theta r plane are not independent to each other. Xy plane is dependent upon theta r plane. X equal to g theta comma r, y equal to g theta comma r. In that sense, x a by theta r becomes dA by d theta r. If that is the case, then their numerator I had made theta r, it also becomes d theta r. Now it becomes dA by d theta r into d theta r. dA by d theta r means if I make one unit of change in theta r plane brings how many area unit of change in A into d theta r. I took any point theta comma r in theta r plane that correspond to a point here x comma y. Consider that point vector is P. Then from here theta comma r I proceeded delta theta and delta r. Then there are 3 points now, theta comma r, theta plus delta theta comma r, and theta comma r plus delta r. Similarly, we have 3 points here, P, P1, P, P2. Now, if I want a dA by d theta r, that is one unit of area change in theta r plane brings how many unit of area change in xy plane? But we have made delta theta delta r unit of change, area change in theta r plane. Then how many unit of area change it will bring in xy plane? That is P1P cross product with P2P, these two vectors. Means P1P cross product with P2P divided by delta theta delta r will give one unit of area change in theta r plane. How many unit of area change in xy plane? And then we saw it becomes dP by d theta cross dP by dr into d theta r, that is d theta dr. What is dP by d theta cross dP by dr? What is dP? dP is xi plus yj. What is x? R cos theta I plus r sin theta j by dr. Cross product with d of r cos theta I plus r sin theta j by dr. One is by d theta, one by dr. Position vector is same. In that sense, one will become r minus sin theta I plus r cos theta j. Cross product with cos theta I plus sin theta j. R will go away. If someone does this cross product, I and I cross product will not happen. I and j cross product. It will become r minus sin square theta. I and j cross product will become r minus sin square theta. Okay, k vector, and j and I will become minus k vector, and here it is cos theta r cos square theta minus k. Mean altogether it become r sin square theta k plus r cos square theta k. Minus is outside. Let's leave the minus right now. Now it becomes r, just r k unit vector. R k unit vector dr d theta is the area vector. Means if I calculate magnitude of this, then it will give the area certain. R d theta dr is the magnitude. What is the integration? R is r square by 2 integration with dr. Radius is from 0 to a, because this is what we have taken in polar coordinate system. It becomes a square by 2. Theta is 0 to 2 pi. 2 pi. Pi a square is the area of a circle. Mind blowing, amazing, wall hitting, head storming. This is the way also we can calculate the area. This is pseudo multivariate calculus. We started with the area, and it becomes area by d theta dr d theta by area by theta r, area in xy plane by area in theta r plane into area in theta r plane. Area in xy plane is dependent upon area on theta r plane. It becomes a by theta r to dA by d theta r. That will also become d theta r because they should be same. dA by d theta r becomes dP by d theta cross dP by dr into d theta dr, r d theta dr minus r k vector d theta dr become the area vector. and then mind-blowing integration, and we got the area of the circle as pi r square. Amazing, mind-blowing. Please do not mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. Plus 91 is the India country code. 9483160610 is the telephone number.